Hello everybody, welcome to my math channel. Please be ready with your books, pens and calculators. We are on page 620 and the lesson we are going to explain today is lesson number 4, circular and periodic functions. Number 1, circular functions. What is a unit circle? A unit circle is a circle with a radius of 1 unit centered at the origin on the coordinate plane, like this one, x-axis, y-axis. This is the origin. This will be the center of the circle with radius 1. So this point will be 1 and 0. This is 0 and 1, negative 1 and 0, 0 and negative 1. This is the initial side fixed on the positive x-axis. This is the terminal side passing through a point x and y. So this will be the x length, and this is the y length, and this is 1. Why this is 1? Because we said it's a unit circle. Now, you know that the sine is opposite over hypotenuse. So y over r, y over the radius, it's y over 1 means y. Also cosine theta, it's adjacent over hypotenuse, which is x over r. X over 1 means x. So the values of sine theta and cosine theta are the y coordinate and the x coordinate respectively. When this is happen? When the word unit circle is mentioned in the problem. Now, this is a unit circle again, and our point of x and y, it becomes now as a point of cosine theta and sine theta. Means the x value is like cosine theta, the y value is like sine theta when the word unit circle is mentioned. Let's take an example. Find sine and cosine given a point on the unit circle. The terminal side of angle theta in standard position intersects the unit circle. So, this is what you are searching for, this word, unit circle. If this word appears, means the first one, which is the x coordinate, will be the cosine. The second one, which is the y coordinate, will be the sine. So, the point P is half and root 3 over 2. Find cosine and sine. Very easy. The cosine will be the x coordinate, which is half. The sine will be the y coordinate, which is root 3 over 2. No need for you to graph. This is just to illustrate what is it about. Now, guided practice 1. The terminal side of angle theta in standard position intersects the unit circle at the point P, 3 over 5 and negative 4 over 5. We want you to find cosine theta and sine theta. Very easy. Since it's a unit circle, so cosine theta is the x coordinate, which is 3 over 5. Sine theta is the y coordinate, which is negative 4 over 5. Of course, if you are asked to find other trig functions, it will be very easy. For example, if we are asking you for the tan, you know that tan is like y over x. So tan theta, in this case, when you divide this one by this one, 5's got cancelled, so it's just like negative 4 over 3. And of course you can find the reciprocals as well. Moving on. On page 621, we need to know periodic functions. A periodic function has y values that repeat at regular intervals. One complete pattern is a cycle, and the horizontal length of one cycle is a period. We have here the theta axis and the y-axis. Obviously, this shape, this V shape, is repeated as long as theta is increasing, as if our graph is consisted of this unit. The V shape is repeated. Now, this V shape is called a cycle, and the beginning of the cycle and the end of the cycle on the x-axis or on the theta axis, it's from 0 to 360. We call it a period. So this graph repeats itself every 360 degrees, means this is the period of the function. So it's a periodic function because it repeats itself, and the period is 360 degrees because one cycle extended from 0 to 360 degrees. Example 2. Identify the period. You will be given a graph like this one. Determine the period of the function. Look at this shape. This shape is repeated, as you can see. So this is our cycle. And this cycle on the theta axis, it's extended from 0 to pi. Also, if we move another pi, we will find the same shape. That's why the pattern repeats at pi, 2 pi, and so on. So the period is pi. Moving on. In example 4, evaluate trigonometric expressions. Find the exact value of each expression. Cosine 480. If the angle is more than 360, so cut out 360, means you can directly subtract 360. 480 minus 360 will give you 120. So you can write cosine 480 as cosine 120. But you know that 120 lies in the second quadrant. So it has a reference angle. Anyone knows what is the reference angle of 120? Yes, the reference angle is excellent, 60. So cosine 120 is exactly like cosine 60. But of course in negative. So it will be negative half. Let's try to find sine 11 pi over 4. 11 pi over 4 is more than 2 pi. How do I know this? Because 2 pi, if you consider this denominator, 2 pi is like 8 pi over 4. And this is 11 pi over 4, means this one is greater than this one. So it's more than 360. So what we are going to do is we subtract 2 pi as we did here, subtract 360. So 11 pi over 4 minus 360 in degrees, which is 2 pi, can be written as 8 pi over 4. We have common denominator, just subtract the numerators. This is 3 pi over 4. Of course, 3 pi over 4 lies in the second quadrant. Why? Because it's very close to pi, which is 4 pi over 4. So now I can rewrite sine 3 pi over 4 as sine its reference angle. What is the reference angle of this one? Yes, excellent. It is pi over 4. Since it is in the second quadrant and sine in the second positive, so I don't put negative here, I leave it positive. And sine pi over 4, which is sine 45 root 2 over 2. Now let's discuss those. Problem 4a. I need to find cosine negative 3 pi over 4. First, transform this angle into a positive coterminal angle. So negative 3 pi over 4 plus 360 means plus 2 pi. This is negative 3 pi over 4 plus 2 pi is like 8 pi over 4. So 8 pi and negative 3 pi is like 5 pi over 4. So our problem now is cosine, instead of negative 3 pi over 4, it is cosine 5 pi over 4. It is the coterminal. And it's better to deal with the positive angle rather than dealing with the negative angle. Now we need to know its reference, because 5 pi over 4 is more than pi, because it's more than 4 pi over 4. So its reference angle will be pi over 4. So this will be the same as cosine pi over 4. But 5 pi over 4 lies in the third quadrant because it passes pi. It's more than pi, more than 180. So it lies in the third quadrant. And cosine in the third, is it positive or negative? Yes, excellent. It's negative. So this will be negative cosine pi over 4. Now you can write it as negative root 2 over 2. Now, for B, I need to find sine 420. This angle is more than 360. So the first step is to cut out 360 to find its coterminal angle, but it will be the least positive as possible. So this will be like sine 420 minus 360 will give you 60. And we know that 60 degrees lies in the first quadrant. So no need to find the reference because it's already in the first. It is the reference of itself. And sine 60 degrees will give you root 3 over 2. By this, my dear students, we come to the end of our lesson for today. Till we meet again, goodbye.